So to refresh your memory, exponential functions, that's when there's a variable in the exponent. And in the first lesson, we graphed ones where the base was a whole number, like 3, 2, or 3, or 4, or 5, etc. And we also looked what happened when the base was a fraction, like 1/2 or 1/3, etc. So this function, which values of x did I tell you to use for a table of values? -1, 0, and 1. Right. 2 to the -1. 1/2. 2 to the 0. 1. 2 to the 1. 2. So to graph it, -1 is 1/2. 0 is 1, which it always is in any exponential function, and 1 is 2. And we see it takes a curve. How do I sketch the curve on the left? How do I sketch it accurately?
It's going down the negative.
Right. Drag it along the x-axis, because it never touches the x-axis. Which means, as part of the graph, we have to add an asymptote. That's a completed graph of y equals 2 to the x. If you don't put the asymptote, you have not drawn a complete graph. Well, we can do a table of values for the next two functions above. I put a table there, but perhaps we don't need to. If you remember how to transform functions. When there's a negative in front of the function, what does that mean? Yeah, flip it vertically. Flip it over the x-axis. So this is just y equals 2 to the x with a vertical flip. So I really don't need a table of values. I just look at the graph at 2 to the x and flip it over the x-axis. So this one flips over to here, this one flips here, this one flips here. The asymptote, because it's on the x-axis, doesn't go anywhere. So the asymptote is still the same thing. This time it's going underneath the x-axis and approaching it. So that's y equals -2 to the x without a table of values. Without a table of values again, how do you think you do this one? Remember, this is inside the function now. We're inside. That means everything that's happening is horizontal. And a negative means a flip. So because it's inside horizontal, because it's negative, it means a flip. So y equals 2 to the x with horizontal flip. Don't need to do a table of values. Okay? So I go back and I look at y equals 2 to the x and I flip them horizontally. So this flips here, this stays where it is, this flips here. This time the curve is approaching the positive x-axis. So again, the asymptote doesn't change. And that's going to happen if we do flips or stretches. The asymptote won't change. If we shift vertically, the asymptote will change. Okay, and we'll see that momentarily. And here's sort of the general equation, transformation equation we use for exponential functions. Remember, if it was radical functions, instead of an exponent, we'd have a radical sign. Okay? So A represents what? Vertical stretch and flip if it's negative. B, flip if it's negative. Yeah, horizontal stretch and flip if it's negative. Remember, the horizontal stretch is 1 over B. H, which way? Horizontally. This, vertical shift. So just keep that in mind. So let's look at a couple of these. And I'm not even gonna do that one, because we were only doing 3 of them, -1, 0, and 1. Okay. Notice I've taken the grid off so that you have to sketch the grid lines. I'm just going to go like this, so 4 notches. That should be sufficient. So 2 to the x we've already seen. -1 is a half. 0 is 1 and 1 is 2. So we know it goes like this. So remember, that's 2 to the x. Now you can do this one of 2 ways. And I've talked about this since the beginning of the year. You can either do mapping notation, get your new coordinates and plot them, or you could do it right off the grid if you wanted to. Like, doesn't this mean take this thing and shift everything 1 down? So we don't necessarily have to do mapping notation. I put it here, but just take every point and the asymptote and shift it 1 down. So the asymptote has to shift 1 down. This goes from a half to -1/2. This goes from y = 1 to 0. And this goes from y = 2 to 1. And it'll look like that. I mean, that one's probably easy enough for you to do right off the graph. Usually with the more complicated ones where there's more transformations, that's when we use mapping notation. But if you did, what would be the formula to change each coordinate? What happened to the x's? Nothing. What happens to the y's? They all move down 1. Okay. So then you'd have like -1, -1/2, and you'd have 0, 0, and you'd have 1, 1. And the asymptote would also move down from 0 to -1. Of the new one, okay, the blue one, what's the domain? Negative infinity, positive infinity. or if you read the other way, XER. What's the range of the transformed one? What goes around the -1? Bracket or parenthesis? Bracket means I include -1. Remember, it's never going to touch -1. So you got to be careful with that, with asymptotes and domain and range. What's the x-intercept? Well, you can just see it on the graph. 0. What's the y? Also 0. Okay. Next one. Again, this is a pretty straightforward transformation. If we did 3 to the x, what do I fill in here? I'm not going to do this one. This would be a third, 1, 3. So 1, 2, 3, 4. So -1 and a third would be a little bit lower to the x-axis. 0, 1, 1, 3, which means it climbs faster. Nice. Well, this one we saw an example on the previous page. You could just do it off this graph, right? What would you do? Horizontal flip, right? Horizontal flip. So everything gets flipped over the y-axis. So this gets flipped here. This is on the y-axis, so it stays. This gets flipped here. While the horizontal asymptote gets flipped, but it still stays where it is. And we get this. Again, you could do mapping notation if you wanted to. In this case, every x would become negative, every y would stay the same. So we get +1, a third, 0, 1, -1, 3. The asymptote won't move. So we're there. Domain of the blue one. Negative infinity to positive infinity. Range. 0 to infinity. What goes around the 0? Parenthesis. X-intercept by looking at the graph? None, right. Never touches the x-axis. Y-intercept? 1. Okay. You guys get the idea. This one's got some more stuff in. So remember, a half x, remember, if the base is the whole number, we're climbing up to the right, but if the base is a fraction, it's like a horizontal flip. Okay? So for this one, -1, well, 1/2 to the -1 is the same as 2/1 to the +1, which is 2. 1/2 to the 0 is 1. 1/2 to the 1 is a half, and we don't need to do this. So we've got negative 1, 2, 0, 1, 1, 1/2. We see that it goes up to the left, but goes along the x-axis to the right. So that's y equals 1/2 x to the x, pardon me. Now this one, maybe mapping notation helps. Because we're doing a couple of things here, aren't we? We're flipping over the y-axis, x-axis, pardon me, vertical flip, and what? Shifting to the right one. Okay? So, I mean, you could do it with the points if you wanted to. You could flip them and shift them each one. It would still work. Okay? This one I'm going to do mapping notation. What would the formula look like? Negative x? X minus 1?
X plus 1.
Remember, I'm moving it to the right, so it's x plus 1 and negative 1. Good. So this gives me 0, negative 2. This gives me 1, negative 1. This gives me 2, negative 1/2. You can see, and you should be able to see what the curve does. As well as the asymptote. Did the asymptote move at all? No. The only time the asymptote will move is if you do a vertical shift. Okay, that's it. That's the only time the asymptote will move. If we do horizontal shifts, doesn't matter. Okay? So we're still at y equals 0. Domain? Range? X-intercept? None. Y-intercept? Don't be so accepting. Yes. And finally, the last one. We've done ones like this before, just using words. Remember, you have to describe flips and stretches before shifts. What's happening here? Vertical stretch. Don't forget the word factor of what? 3. Doesn't flip. Okay. Horizontal shift. Left 4. Yeah. What do you?
I was talking about the 2.
That's the base. That's the function itself. Yeah, that's not a transformation. No, the 2 would have to be in the exponent in front with parentheses. Yes. Finally, vertical shift. Not 2. 2 off. Good. So that's it for graphing exponential functions and their transformations. Next, we do solving exponential equations. So that would be something like this. I'll give you, like, you guys know how to do some of these already. Solve for x. Yeah, because you just know 2 to the third is 8. Okay? -1. Right? Because if it's going to change to a fraction, the exponent's going to be negative. Okay? So we're going to be taking ones like that, but then we're going to be taking some more complex ones. Okay? But not much more. Okay. So you can now work on 7.2.